Alright, so for today I want to create a game in Raylib using C, and yeah, I've created games in Raylib before and also used my own programming language to do that when I ported Raylib to Cool. But yeah, I want to create a really simple game in C. Let's see how fast we can get it going. The game I want to implement is uh, 2048, I think that's how it's called, and it's basically pretty simple in my opinion to do. We have this square 4x4 matrix of tiles, right? And we can do certain actions like move right, move up, down and left, and when we do a certain move, then the numbers that are matching, they add up together. So this is the style of game I want to try and complete, right? And obviously the objective of the game is to get to the number 2048, and if I guess this guy actually got to 16,000, but I think it's not possible. And if you fail, like if you complete all the cells and you cannot do any moves, obviously you lose. So yeah, this is the game that I want to try and do. So I guess the first step is to set up the project, and I have an older project which I also have a video on, like or I guess a couple of videos on. It was the particle simulation in C, which used Raylib, and yeah, to set up Raylib I think I'll still use CMake. I think it's also possible to just download the compile library and build it that way, but I feel like it's easier to just copy paste an older CMake of mine. So yeah, like CMake list.txt, right? So let's actually try to get it going. So I'll use the client compiler, right? And this is the part that downloads Raylib. So it just puts here the Git repository. The tag is gonna be the main branch, and yeah, I think that's all for this part. And let's do like project, it's gonna be main, I guess, and or I don't know, I mean I cannot call it 2048, I'll call it main. The executable is gonna be this one, cmake current list dir, so I'll have a main.c file in here, I guess, and private library at Raylib, right? That's all that we need, I think. But first let's start with main.c. Let's do include stdio. I almost went with println. Yeah, too much rust in the hello world new line. Okay, so yeah, this is all for this. And to actually build and fetch Raylib, let's do a build folder. Let's cd here, cmake, like that. I mean, I have no idea why the build process is like this, but it is what it is. This should, I think, download Raylib and compile it probably. So yeah, I mean, this is the hello world of Raylib. I guess we can also take this one after we it compiled, and this one is for the LSP if I remember correctly. So it gives us a file for ClankD for the language server to work with NeoVim, and this one should just build everything. Hopefully it's gonna be fast enough, yeah. And build main should just show hello world, okay. And if we try to use the hello world example from Raylib, we should see like a window when we build. Okay, so yeah, I mean pretty neat. So I think the way the game will look like is gonna be just a square, so it's gonna be exactly like this. I won't show any score or anything. I mean, I think the score, if I remember correctly, was what, like the sum of everything on your screen. So I mean, yeah, and you know, probably we'll use just arrow keys and we'll show just this, so we can make it like 512 by 512 or something, and should be enough, right? So why not? Let's just try it. Let's see how small, I guess. So 2048, right? I mean, I have to rebuild it, not forget. So yeah, would be quite small, but should be enough. So yeah. So I guess the first step in this game is to draw the grid, right? So we need some background color, right, for our game. So I can close this project. I mean, I'll link it. So I think I need a readme for that. I don't know where to keep this, so I'll just keep like a list of links to add to the description if you're interested in seeing that older projects. Or I'll also, I think I have a playlist, and I'm not sure though, but probably there is one or two videos that are interesting of this paper. I mean, there's also the demo. I think the demo is cooler to visualize, but yeah, if you want to check it out, it's in the repo. So yeah, let's try to although I feel like the easiest way to check the docs is actually go into raylib.h. So actually I figured this out when I was porting Raylib to Cool, and it's just easier to look in here, find what you need, move it. So let's also, I'm also using Harpoon, so I'll just add these two files, right, so I don't have to grep for it. Okay, so first things first, yeah, we need to clear the background, right? So let's use something like dark gray for that, why not? And let's see how everything looks like. So let's do build. I'm still having the history from okay, so whatever, it's the background, right? The next thing would be to actually draw the cells, and I think the data structure I'm gonna use for the cells is gonna be just a 2D array. So I'm gonna do something like it's gonna be an int array. I think that's a good idea because we are gonna have world. Should it be an array, like a 1D array or 2D array? Like should be a 4x4, everything with zeros. Man, I don't remember how to do this in C. I think it's the type, right? So should be like this. Oh, like pretty sure it was like that. Okay, yeah. Anyway, whatever. So it's gonna be zeros if it's declared globally anyways, so that's fine. So yeah, and I think that if I'm gonna have 0, it's gonna show nothing, and if I have a number, it's gonna show that number, right? So that's also a thing. And I also think I want a mapping of background colors, right? So let's do like colors. This should be what though? It's gonna be like a mapping. So it's gonna be a mapping of the powers of 2, basically. So, just curious what the type of this thing is. So it's a define. It's a color. I mean, it's a color, like literal, yeah, sure, whatever its color. So it's going to be a color array, right? And a good question is how many colors do we have? So I guess 2048. But I mean, it's not all the powers of 2 though. So yeah, anyway, we'll see how we deal with that. We could have a function, so color, I guess that's easier because we don't have hash maps in C. And I guess I could use my the library ds.h data structures, but I think it's fine to just use a function. So color mapping. So this should take in the number, right, and return the color. So I think like map color, right? I think this is how it should look like. And obviously if the number, should we do a switch statement? If the number is equal to 0, then we can do light gray or something. I guess should be like a light gray. Return, right? Or I guess, yeah, but we won't have any other numbers other than 2, 4 and so on. So even a switch could work over a number. So it's gonna be something like, okay, if it's a 2, like case 2, oh, we have a case 2, then it's gonna be return, and I mean we can do any color, so I guess blue. Dark blue. I don't know all the colors from Raylib, but I think it's like blue, sky blue. Let's use blue. And on the default case we can return light gray, so any other color is gonna be light gray. Okay, so how can we actually draw this this world, right? So maybe let's do a define grid size for, just to not use numbers like that everywhere. Makes me a bit more sane. Wait, what? Oh, yeah. Let's ignore the issues. So again, here we should do a for loop. I don't know, I just do it. For int I is equal to 0, I up until grid size, right, and then for int j is equal to 0, like that. We should draw some rectangles, right? And sure, we should have also some padding, some rectangle size and whatnot. So maybe even this thing is gonna be a bit more different. It's not gonna be 512. So we'll see. Maybe define cell size. Maybe the cell size is gonna be 64. Define cell padding, which is gonna be the spacing between I guess everything. So let's say it's gonna be 8 pixels. So define the window size. I think the window size is gonna be what, like grid size, right, multiplied with the cell, and then we have 1, 2, 3, 4, 5. So it's gonna be something like grid size multiplied with cell size, right? And we could use parentheses around everything, so like this. And we also need to add grid size plus 1 multiplied with cell padding. And yeah, let's not forget about the parentheses. I think it's enough. So that's gonna be the window size. Okay, let's see how big it is. Okay, pretty small. So we could make these a bit bigger. So let's say it's gonna be 128 and 16. It's like twice as big, right? So I think this should look decent. And now let's actually try to draw these things, right? So let's try to see inside of Raylib. We should have something like draw rect. Great, draw rectangle. So it's gonna have a position X, position Y, width, height, and color. So for the width and height, we know it's gonna be cell size. Cell size. For the color, again, it's gonna be simple. It's gonna be just map color, right? Map color, and we pass in I and J. So, I guess we pass in world of I and J, and I think I want to use row and column for that. So I can say that this is gonna be the row and this is gonna be the column, I think. Doesn't really matter, but yeah. And for the cell position, now that's gonna be more interesting. So int pos x, how can we get the position on the x-axis? So it's gonna be something similar to this, right? That's how it should be. So it should be column multiplied with cell size, and we should add column plus 1 multiplied with cell padding. That's the position X, and position Y is gonna be a row, right? So pos X, pos Y. Okay, and let's see what do we get. Well, pretty cool, right? We get the empty cells because we have zeros. Okay, so that's pretty cool. Now the next thing should be to draw the text. So draw text. I mean, I guess this had draw text, and we can put something here. I guess the position, the size, and the color. But this one should happen only if world row and column is not 0, right? That's how I think I want to do it. So we have the text, right? And for the text, let's see if draw text pro has no. I mean, I just wanted to avoid actually we have of convert a string to an integer, but how about converting an integer to a string? But I mean, you know, we can do sprintf, and then actually sn printf, right? And here yeah, usually I do just like the required length, and I do sprintf, right? And here is the buffer, which is going to be null, and then we have something like %d. Oh, and instead of doing this so many times, let's just have a variable like a number, just because it's easier, right? So number, we just put a number, right? And if you use sprintf with a null argument, it's gonna give you how much space it needs to write that string. So then you can actually allocate a string and yeah, like have a char pointer. Text is gonna be malloc required, let's say +1. We could actually use calloc, calloc. Oops. No, calloc. And let's use size of char. Right, so calloc also initializes with 0. Okay, and then we can do sprintf, but the other thing which I feel like we could do, because this one is pretty stupid, is have a const char pointer map text, because why should we not do this thing instead? So it's just easier. Right, so if we have a 2, it's gonna be a 2, and otherwise it's nothing. So then it's just a matter of putting here map text, we pass in the number, and oh yeah, you know, I remember from a cool compiler from library, when I added Raylib for text, we had this measure text function, which is pretty cool. You give it some text and it gives you how much space it takes, like in a matter of width. So measure text, it's actually pretty useful. But I don't remember. I guess we'll see if it crashes. Okay, so give it some font size. Let's have the font size also number font size, or I guess just font size is gonna be what, maybe 48, but let's start with something smaller, like 24. I'm not sure how big is the font size. Right, so measure text is gonna give us the width, so int width, right, is gonna be how big the text is. So for I guess position x and position y, we can just compute them. So position x is gonna be I guess this is the corner, so we could say text x is gonna be position x minus width divided by 2, and the text y well here I think we also need to add cell size divided by 2, and position y maybe something like this for starters. I'm not expecting it to work first try, but font size, and this should maybe be Raylib white. Okay, so thing is, right now we don't have anything, so let's say that maybe world of 1 1 is equal to 2, or let's say row 1 column 2, right, is gonna be a 2. That's cool, although it's a bit too down, so I think we also need to subtract font size divided by 2. I think font size is just the height, so let's say the height is gonna be maybe 100. Kind of too big. Once it's gonna get to large numbers, it's gonna be way too big. So let's say maybe 64. Right, I mean, this looks decent, I would say. No, we just need to add all the colors, all the numbers, but let's see. So usually when wait, I think the game is actually available, so I think it just spawns two things right here. So yeah, I think we can try to do that too. Well, actually I wanted to see the images. So I think it just spawns 2 of them randomly, right? So void world init, we could just srand see random number. I don't remember how to get the random numbers, so I need time, and I need time for this one. So yeah, I will need those. Actually, I think I need stdlib for random. So let's do srand time null, right? And let's, this way we could use a random number, right? So let's say row 1 is gonna be this thing modulo grid size, and row 2 is gonna be also number. We should just make sure that we don't get the same thing twice. And maybe the other thing is, should we maybe just have a 1D array? Like, why not? It makes life a bit easier. So index is gonna be row times grid size plus column. So this is gonna be the index. It just makes stuff a bit easier. So that way we could just say index one is gonna be random, define world size is gonna be grid size multiply with grid size or something like that. Right, so world size. Okay, so this is gonna be the first place where we want to spawn a 2, and I guess, you know, it doesn't really matter if we spawn in the same spot. Like, does it really matter? Index 1 is equal to 2, world index 2 is equal to 2. So yeah, basically we also have to call this, so world init. Right, and let's say memset memset takes in void pointer, so I guess world, maybe the value and how much, world size. I think so. Set n bytes of s to c. Yeah, so just to reset the world basically. So yeah, and let's say that if you press R, if key down is key down or key pressed. I don't remember if key down checks if you press it only once, or key down, key R, then world init. Right, so if you press R, we should just, this is a bit weird. Huh. I thought excuse me, what? World init. Really? For int I is equal to 0 less than world size. That's really weird. Like, why wouldn't it yeah, but it's also because I'm doing srand each time here. I should maybe do it once, and now it should be more random, so, or at least faster. Yeah, so I saw in the beginning it sometimes it actually generates the same number twice. That sucks, but you know, sucks to suck, what can I say. Like, one way to maybe fix it would be to do a while loop, and do a while loop until these two indices are different. Or the other one, maybe would be, I don't know, some computation thing, like do a random between 0 and index 1, and the random between index 1 plus 1 and world size, and then choose the winner from those two. But you know, I don't feel like doing that. That's trash in my opinion. There's no point. So more fun to actually do the actual gameplay. So let's see now how we can make this thing. So when you press the arrow keys, when you press them, to actually move the cells in that direction. So that's the next thing to do. So I guess direction doesn't really matter, so we could have a single function for slide, let's say. So let's do something like void slide cells, right? We don't need anything because we have like global world, so it's just slide them. Maybe we'll need a direction, but for now let's hard code it to be, I don't know, right or something. So if we slide the cells, we actually need to check the entire line or column. So we need to check from the opposite direction. So I mean, sure, let's have the direction passed. I don't even know how can we look at the direction. I feel like it's easier to just have a function for each one. So slide cells down, let's say. So if we press the down arrow key basically, and let's see what happens. So when we do the check, we should probably start to look at this row, and then this one, and then this one, and so on. So if we have like a 2 and then another 2, we know that it should convert to the next number. But I guess if the two numbers are equal, one after the other. Oh shit, like damn, it's a bit tricky. So yeah, like we should check. Well, here is nothing, so the next cell can come down. Then we find a 2 or like any other number, let's imagine. So we also have that number, and then we find a number that's equal, right? So let's say we find 2 4s, like here for example. So we can add them together. I guess we can split this into 2 parts. The first part would be computing the eventual merges and then sliding it. So let's say that when we slide cells down, we do a for loop over the rows, or I guess over the columns. So column is equal to 0, column is less than grid size, and column plus plus. Fuck, I made a happy face. Okay, so this is the first for loop over the columns. So now we need to look at a vertical slice. Right, we need to look at this slice of numbers. And I guess what's interesting, we should look at it from the reverse order, so from bottom to top. So we look at the first one, first line, and what if we don't find anything? Well, then it's nothing special happens. Then what if, I guess we could use for ifs, because we know it's for things, but yeah, I don't want to hard code it that much. So it's gonna be like a for loop, right, over all of these things. How can we, I'm just thinking in terms of doing like a reduce, you know, like in like a fold operation. So I guess, as I said, I'm gonna put all the numbers from here into a slice, and then try to merge them. So the first step is to create a new int array. Let's call it slice. Right. This slice is gonna have grid size elements, and it should be initialized with zeros. Right. Then let's do a for loop over the rows, starting with grid size -1. And let's say while this thing is, should I do like the, I think, greater or equal than 0, row minus minus. Right. And now I'm just gonna say, also need the index, so index is equal to 0. So I'm gonna say, I need another index, so let's keep this one. This one is computed the same way as it is here, so like that. If world index is not 0, then slice I think I can do I++ is equal to world index, maybe. So I'm just getting the slice of numbers, right? And now I can have a function void merge slice, and this thing should get int slice, probably should be like a pointer thing, so I should be able to make changes to it. Right. And then we should have another for loop, int row is equal to grid size -1, row minus minus, and I think I want to reset, so I'm gonna do like merge slice here with the pointer, so slice, and I think I want to set back the slice, so end slice of row is not equal to 0. That's when we stop. So world index, obviously, is equal to slice index. I mean, it's just mem copying basically. I want to copy from slice to wall, but yeah, whatever. So I think this is how we slide the cells down. So I'm going to do here something like if is key pressed key down, slide cells down. Nothing happened. Wonder why. Let me do like a print f %d like I and world index or something. Let's also do a new line. Really, I need the yeah, okay, anyway. So 1, 2. So I mean, it works to some extent. Oh, yeah, I know why. It's because I said this this thing. So here, damn it, I need the I again, apparently. So I is equal to 0. Okay. I plus, like, it doesn't even matter that we copy zeros. So yeah, now we actually are able to move these things down, right? So that's pretty important. Anyway, let's delete that. Oh, and I think I could also put I into here, so it's just less declarations. Okay, so I think this is how we do slide cells down. Okay, perfect. Now let's do slide cells up, because it's pretty similar, but I think we start with 0 here and we move up. So less than grid size and row plus plus, and here is the, it's also the reverse, so let's just copy it. And if we press up, slide cells up. Should I do like else? Okay, so looks like it's working, but as you saw here, it doesn't merge them, so that's what I want to be able to do next. So because it's like a proof of concept, sliding up and down, let's try to merge these things. Let's try to merge them. So how can we actually merge the two numbers? So we should have a for loop again over the slices. So for int I is equal to 0, I should be less than grid size. How did that get in there? Right? and maybe we should go -1 here because I want to look forward one step. So if slice I is equal to slice I plus 1, then usually what would happen is that slice I is equal to, you know, slice I plus basically slice I plus 1, right? This is what would happen. And I'm not sure, but I think it also breaks. Like, does it work like that? Only the first one is done, or is it for all of them? I don't remember quite sure, but well, actually I think it's for all of them. So if you have 4 2s in a row, it does that, but it doesn't merge. So let's say we have I don't know how to draw it, so maybe GIMP. So let's imagine we have something like 2 2 and then a 4, and you go down and it converts to a 4 4, so it doesn't do an extra step, right? It just does that. But you have 4 2s, you go down, you're gonna get 2 4s. That's how it should work, I think. So merge slice, let's see what happens if we do just that. So this one, okay, let's try another one. So I think right now if I go down, this should turn into a 4, but this is gonna stay. Oh, this is not gonna work. No, it is gonna work, but this is gonna stay as a 2. So oh, but we don't have the display for a 4. I forgot about that. So if it's a 4, let's do, what's the next color that we can use? Should we do purple? And if it's a 4, then we have a 4. Right? So it turns into a 4, but this one is not deleted, so that's what I want to do next. So I guess slice I plus 1 becomes 0. Or the other cool way to do it would be to shift everything. So that would be way cooler, but we cannot use I++ here if I do that. So how can we do it easily? Yeah, I mean, I think I have to just do that because it's gonna make things a lot more easy. So if I find 2 numbers that are equal, then I have to do a for loop. J is equal to I plus 1 up until grid size -1, I think. Yeah, up until, damn it. So I have, okay, I find 2 numbers that are equal, right? So it's something like this. Let's say it's a 2 and a 2, and maybe here is another 2. I go down, so this comes like a 4 here, that becomes a 4, and this is the I position. So we look above. What do we have to do? We have to delete this thing and replace it with what's above it. So this thing becomes a 2, this thing becomes what's above, so a 0, so 2 0 0. So I have to go -1 here, j plus plus, and then I have to say something like slice j is equal to slice j plus 1, and the only issue is that slice grid size needs -1 needs to become a 0 because it's the last one. So yeah, it's j. I think this should probably do it. So if I run it, oops, something doesn't work. Wait, is it an infinite for loop or oh, I forgot about that. So yeah, we don't increase the I, but on the else case we do. Right? Or am I wrong? Oh, it doesn't work. My idea was that if I find, I think I have to increase I don't know why I'm not increasing it. Right, that seems to work. So I iterate all the i's, and if I find two equal numbers, then I replace the current number with the sum, because that's what it basically is, and then I take the next numbers and shift them down. So then I go to the next one. So it works. Yeah, it should work. So this is how merge slice works. So let's do the other ones. So slide cell to the left and to the right. Okay, so left, and now since we are doing to the left, we need to put the rows first. But it's still gonna work with the same slice. So we iterate all the rows, right? We build up the slice for a column, or I guess for our row. We merge it, and then we need, well, I need this I here, and then we merge it back in. But I mean, this is the left one, so left starts with 0. Yeah, that's fine. Left starts with 0, and right starts with the other one. So let's take this one, and if we try to move to the right, it should be here grid size -1, and this thing greater than 0, column plus plus, and this thing comes also here. So I think this is everything for moving the thing. So if it's key left, whoa, what? Yeah, it's key left, we move left, and if it's key right, we move right. Oopsie doopsie, right. Okay, let's see. Okay, yeah. Oh shit. Okay, right doesn't work, but everything else seems to be working. So for right, slide cells right. What might be the mistake? Oh, yeah, minus, whatever. Okay, so now it's it just works to move around, but we don't spawn any new squares. So that's the next step. The next step is to, after we do a slide, right, we also want to spawn a new a new cell. And yeah, so I guess that's gonna be similar to world init, although I think we can also spawn fours. Spawn new. So let's define int index, which is gonna be 0, or I guess it could be a random. Now while actually should I just do something like for, I guess, int length is equal to 0, and for int I is equal to 0, I is less than world size I plus plus, if world I. So I'm thinking, let's count how many zeros we have, right? Well, what? Okay, so we have all the zeros, right? And I guess we need to do something like length here, so we get which zero to replace, and then we have another for loop like this, right? And int I is equal to 0. Oh no, I guess we could also do int j is equal to 0. Okay, and here if index is equal to j, world I becomes a 2, and we can break because it's over or something, right? Oh, but I don't call that. So world spawn new, I would say let's world spawn new. Holy shit. It's almost playable. We don't have the... I'm curious what would happen if I fill up the entire thing. And like, does it crash? It just doesn't work, so that means that, okay, it doesn't crash, but we have to check something like, after we do world spawn new, do we have any other empty spaces? And if we do not have any other empty spaces, then we just lose, basically. So let's do like int is over, or I guess is game over. We are gonna do the same thing as we did here. Oh, I guess it's even easier. Return 0, return 1. So if we have any space with a 0, it's not game over, right? And I mean, I'm too lazy to do it there, so I'm just gonna do if is game over, then we just world init or something, right? So that's the idea. If you lose, then it's just gonna say game over. So let's try to spam until we get to a losing state. Or I guess, you know, you don't really lose if you fill up the entire space. Yeah, we have to do is game over in another way, because you usually lose if you don't have any spaces left. Okay, let's do some other colors. So let's use green, I guess, for 8. Green. Let's use red for 16. Red. Pink, why not? I mean, it's close to the orange. For 64, it's gonna be orange. Okay, I guess I want the colors to also be visible, so let's do gold. So 8, 16, 32, 64. Sure, it would be much easier to have a function for that, but okay, let's see. So, oh, and it's also I was thinking, if nothing happens, there was nothing spawned, I couldn't really figure out. So no, it spawns, yeah. Huh, strange. But yes, seems to work just like the normal game. So yeah, but we need a lot more testing, right, to be able to say for sure that it's working properly. We got the last number that we have available, so yeah. No, I mean just spamming the like right should work. What next? I was hoping for that one. So yeah, now we run out of numbers, but yeah, pretty cool, right? I don't see any bugs right away, so let's just add more numbers. So 256, 512, 124, 2048. What colors can we use? So instead of gold, can we use maybe brown, beige? I don't know what color this is, but I saw it. Okay, let's try lime. I mean, instead of gold, I mean, let's leave gold for the real one. Let's have violet. Why not? Okay, so 256, 12, 4, and 2048. So yeah, now we have more. So I could just say, let's just see how the colors look like. So we could do here like a for loop. For equal to 0 to 11. I is less than 12, I think. Maybe 2, maybe 1. Number is gonna be like this, I think. So world number. So let's see if we got all of them. Oh yeah, we got all of them. I mean, the text is too big for but yeah, we got. Okay, so oh, I guess it doesn't work because we have an extra number here. That's too big, so let's do 11. Alright, so we actually beat the game. Holy shit, we beat the game. Let's do the font size 50. Let's make it a bit smaller. Okay, so now it looks good. Alright, so we have all the numbers. Huh, it's a bit weird. Why doesn't it show up? Two shifted, like by 1. Fuck. Print F. It's so weird. Number. Let me just do a new line. Like, I think the first one should be a 2. Whatever, you know what? I'm not. Like, isn't it 2 shifted? No, it doesn't matter. This was just for testing the colors and stuff, so it's fine. So yeah, I think the game looks fine for a speedrun. The only thing is checking if it's game over. Right, so but that sounds like an interesting problem, because we have to just check if there are empty cells. That's the first check, and the second one is to check if there are no numbers equal to each other right next to each other. So yeah, I feel like it's I don't know. But at least we you know, we got the game. I don't know how to play though. Okay, but it feels like the actual game. So yeah, like that's pretty cool. Okay, so yeah. let's see how we can make is game over first. So is game over. Okay, it's up there. So as I said, first things first, if we find any empty cell, then it's not game over, right? But if everything else is filled up, we have to do a for loop. And I think I want to do it like this with rows and columns, probably. Smaller than grid size, yeah, and row plus plus. So that's how I think we need to do a for loop here. And maybe check with all the other neighbors. So at the same time it should be like less than 1 for everything. And I think I want to check only with the down and right neighbors. That's the only thing we need to check. So int index is gonna be computed pretty much the same as here. Left, or I guess right. Right is gonna be row times grid size plus column plus 1, and down is gonna be row plus 1 times grid size plus column, right? And if world index is equal to world right or world index is equal to world down, then we return 0. Let's think, is this how we do it though? Or should I do 2 for loops, I guess? One for the columns and one for the rows. So it's gonna be column is equal to 0, it goes up until everything, then we take the, well, let me just copy paste it because it's gonna be the same thing twice. So we go for all the columns, right? We go through all the columns, then all the rows. Take the index and we loop down, and that's the only thing we do here. We check that there's nothing down, and then we do the reverse for loop basically. Oops. So I can just say it like this, and yeah, I think this seems fine. Right, so this one goes through all the columns, so looks at all the rows. Is it though? Yeah, I guess it's just like going like this, and the other one is like this. So yeah, it looks from top to bottom, and if it finds two of the same kind, it's not game over. So here I can say if is game over, then we just world init, and maybe printf you lost, haha. Now I guess it's gonna be difficult. I mean, is it gonna be difficult to get it to a losing position? I don't feel like it should be that difficult. Okay, let's try to fill up everything. So now if I go down, it's not spawning a new thing. I guess my spawning doesn't work. But it's like if you go down and it doesn't work, it shouldn't spawn, I think. Yeah, so spawning a new thing doesn't work. Okay, so world spawn new didn't really work as I expected. So it found something, let's say of length 1. So if I do modulo by 1, I should get a 0 back. Right, so I guess this should be first then. If index is equal to j, we stop. Otherwise we increase. So now, see, if I go down and it doesn't do anything, it's still gonna spawn stuff. I don't remember if that's how the game played. But not really. Why is that though? Because I literally say index. Honestly, I don't know if modulo by 1 does anything, but it should give you 0. So like index is gonna be 0. The hell? Let's do printf %d index. Okay, let's do it like this. So at some point it's just gonna block, right? So it's saying 0, which is good. So, oh no, what the hell am I doing? So if index is equal to j and world is equal to 0, so I guess this thing should be placed inside of this if. Okay, I think that was the bug. Okay. So it's not yet game over because we still have moves, right? It was still not game over, but probably it was because of world spawn new right there, because length was 0. So I guess if length is equal to 0, we just return, because we cannot spawn a new one, and I don't really care that we cannot spawn a new one. So let's spam this mofo until we get to a losing state, and it's like almost losing state. Let's go again until we actually lose. You know, it's funny that if you go down every time you get this pattern. Never thought about that. See? Pretty interesting. Is this a strategy for this game? But I mean, I just wanted to get it to a losing state, so I'm gonna do something like this. So, still have moves. My god, let me lose, please. Okay, so yeah, that was a lose. Perfect. And it just restarts, so that's great. So we got everything working. Now again, should we spawn new stuff only when you move the board or when we press the key? I think, I don't remember exactly, but I think it's fine. Right, I think it's fine. And yeah, here should be like a 2 or a 4, but I don't know the exact percentages, so I'm just gonna let it a 2. So yeah. So for is game over, let's also do int is game win for I is equal to 0. Let's go up until world size, world I is equal to 2048 or something. Turn 1, and otherwise we return 0. Right, and now I guess before losing, if is game win, because you might lose while winning, if that makes sense. Like the move that you made caused the win, but at the same time you win. And then we were limited. Like it's a winning move, but somehow you also lost because of it. Okay, so let's just spam it a bit. Pretty cool, right? Huh. Okay, just to check that everything works, let's do is game win when you get to 32 or something. That's pretty easy to do. Yeah. Oh shit. Yeah, it works. Perfect. So I guess the game is complete. it took us only, let's say, 250 lines of code, like quarter of 1,000. And yeah, I think it also took us like 1 hour, maybe even less, if we don't take into account the time I spent playing the game. But yeah, pretty good speedrunning. So yeah, I mean, we managed to complete the 2048 game in like 1 hour, which, I mean, yeah, quite a lot of time, but no, pretty neat at the same time. Yep. Obviously, I'm not gonna spend time now trying to win it, but maybe I'm gonna do that. Who knows? You won't be able to see that. So yeah, I mean, I'll also, you know, link the repo so you can just download this stuff and play it yourself. But maybe in the next part we'll try to do it like do the JavaScript bindings for WebAssembly for this. That could also be interesting, trying to release it as a WASM project. Yo, 256, we got it. The color of crap. Okay, let's see. Yeah, I mean, I'm not gonna try to I just, yeah, whatever, let's stop. So yeah, basically that's the 2048 game in Raylib. Pretty short code. I guess you can implement it in a better, fancier way with other languages, maybe even with C, but I just went for the easiest thing, trying to speedrun the game. So I guess trying to speedrun the game implementation. So yeah, I'll post this one and we'll see in the next one. So see you.